In this section on 12.1, we are not going to cover all the topics, but we're going to cover just the topic of composition of functions. So the first thing we need to talk about is just the definition and the notation that's used for this idea of composition. What you'll see is either this f circle g of x, which means f composed with g of x, or you'll see it as like a nested set of functions, so f on the outside and then g on the inside, or the other way around. But the idea is whichever comes first in the f circle g is the one that's on the outside when you put it as a nested set of functions like that. So if we have g circle f, then the g is on the outside, and then f, and then x. And like it says here, what we're doing is we're first applying f to the input x. So we put x into f. Then we take that answer or the result and put that take that for the input into the function g. I was looking at this second line here, but you put x into the inside function, or the one that it's sitting next to, get that answer and put that into the next function that's on the outside. So if I have f composed with g of x, first thing I want to do is rewrite that in this nested form. And I want to start always working from the inside out. So I want to replace g of x with whatever that is. So I'll put g of x is, in this case, x squared, right? Because g of x is x squared. So I replace this input with that expression x squared. And I take x squared and use that as my input for f. So f of x squared, instead of x minus 5, would be x squared minus 5, right? So that means f circle g of x is a new function, which is x squared minus 5. So you can kind of see the first thing that happens to x is it's squared, and then the second thing that happens is there are 5 subtracted. So we have a squaring function first and then subtracting 5. Just to compare, let's look at what g circle f of x would be for this example. Then g would be on the outside and f on the inside. And so we would replace f of x first and use that as the input for g. F of x is x minus 5, so I replace this expression that used to say f of x with the formula or the pattern for f of x. And now I use x minus 5 as the input for g. And g takes the input and squares it, so this would be the group x minus 5 squared. Right, so they're different things. So g circle f would be x minus 5 squared, but f circle g is x squared minus 5. Next example, different functions. We now have f of x equals 3x plus 2 and g of x equals 4x minus 5. And again, we want to look at both f circle g of x and g circle f of x. So let's look at this one first. F circle g, if we switch to this notation where we've got it nested, leave f like it is, and rewrite, instead of writing g of x, we'll write the rule or the pattern for x minus 5. And now we'll take this whole group and use it for the input for f. So that's going to look like 3 times replace x using the pattern for f plus 2. Right, so the f does 3 times the input plus 2, so we want 3 times the function g plus 2. So when we simplify, we've got 12x minus 15 plus 2 is minus 13. And if we look at the other way around, g circle f, first write it as our nested g of f of x. So leave the g alone, work from the inside out, replace f of x with x minus 5, the rule. Oh, sorry, that was the wrong f. The f in this case is 3x plus 2, so we want to replace f of x with 3x plus 2. And we want g of that, so we put this expression as the input for g. So this would be 4 times, put this in where the x was in g, minus 5. So not quite the same. We've got 12x still, but now we have plus 8 minus 5 is plus 3. So again, we see that f circle g and g circle f in this case aren't the same. Alright, if you haven't already, why don't you pause the video and try a couple of these on your own and then see if you get the same thing I do. New functions, absolute value of x and 3x minus 1. F circle g we'll look at first. F of g of x. So f on the outside, replace g of x with its rule, 3x minus 1. And now take this expression as the input for f. So f, the pattern says take the absolute value of the input. So this would just be absolute value of this whole group. Then g circle f has g on the outside, f on the inside. Work your way from the inside out, so replace f of x, which is absolute value of x. And now take that as the input for g. So here we're taking this expression and putting it into the function g, where the input is. So we keep the 3, but now we put times the absolute value of x, minus 1. Just to see a little something different, what if we wanted to evaluate this as a number? So if I have f circle g of 2, for example, we could just use this pattern, 3 times 2 minus 1 absolute values, or we could look at this way too. We could say, well, g of 2 is 3 times 2 minus 1. So g of 2, if we work from the inside out, g of 2 would be 5. And then we take 5 and put it into f. So we have absolute value of 5, which is the same as if we'd gone straight to this absolute value of 3x minus 1 and put x equals 2 in there. Okay, a couple more. If we've got f of x equals cube root of x and g of x is 8x plus 3, let's find these compositions. F circle g of x, or f composed with g. We're taking x and putting it into g first, which would give us 8x plus 3. So we write that down, keeping the f on the outside. And then we want to put that function into f. And f does the cube root of whatever the input is. So this would be the cube root of 8x plus 3. It's tempting to look at that cube root of 8 sitting there and say, oh, I could simplify that to 2, but that 8 isn't a factor of this expression. It's only a factor of the first term. So we really can't do anything to simplify that any further. All right, g circle f would be in nested form g of f of x. So leave the g alone and replace f of x with its pattern or rule, cube root of x, and now take cube root of x as the input for g. So now we're going to have 8 times the cube root of x plus 3 instead. So it looks a little bit different. Let's do an extra one on this one too. If I have, we haven't composed a function with itself, but we can do that too. If I want to talk about g of x, I can do this. And I do the same thing. I work from the inside out, so I leave the outside function g there and replace the inside one with its rule, which is 8x plus 3. So, and then I want g of this expression 8x plus 3. So I take the structure for g again, which is 8 times the input plus 3, and my old input was 8x plus 3, so I have 8 times that whole expression plus 3 again. So if I simplify, I'd have 64x plus 27, 24 plus 3. And then this last example here is, again, just doing these compositions with numerical inputs rather than variable inputs. So let's take a look. If I have f circle g of 2, I can do something like this. Again, write it as a nested set first, or a nested expression. So then I've got f g of 2 is 8 minus 5, so that's 3. And then f of 3 is 9 plus 2 is 11. Right, so just do one step at a time. Find the input on the inside and use that as the take the input 2, put it into the inside function, and take that answer and put it into the outside function. The other way around, g of f of 2, got g, and then f of 2. So first calculate f of 2. F of 2 is 6 plus 2 is 8. Put that into g. G of 8 is 32 minus 5 is 27. Yeah, so that's composition of functions. Let's do one more. How about if I want g of 3? So then I'd have nested, it would look like this. Calculate g of 3 first, and that would be 12 minus 5 is 7. So then the outside function g we want to evaluate at 7, and that would be 7 times 4 minus 5 is 28 minus 5, so 23. All right, good luck. So remember, in 12.1, that's the only one of the topics you're responsible for.